morning, good afternoon, or good evening, whichever applies to you. And welcome to Chef Comp 21. I am Benny. I am the manager of community and developer relations here at Chef. I'm joined today by Cliff Sabaggio. He is the principal engineer at Shine Solutions in Australia. He's here to tell us about InSpec, why you'd use it, how you'd use it, and what you want to avoid. So go ahead and take it away, Cliff.
Thanks a lot, Benny. Good day. Hey, everyone. And thanks for taking the time for watching this presentation. Today, I'm going to talk about the journey to improve the infrastructure compliance of one of the projects that I worked on some years ago. And it was done by utilizing Chef InSpec as the testing framework of choice. And to start with a little bit about me. So I'm Cliff Sabaggio. I'm a principal engineer at Shine Solutions in Australia. And I've been working on projects around cloud infrastructure for the past 7 years. Today's talk will be divided into 6 parts. So we'll start with how this journey started back then, and then how InSpec came to the rescue, and then how we look at custom InSpec profiles and what we did there. We ended up open sourcing these profiles, and then we move on to how we use the Chef Supermarket to register these profiles and distribute the profiles. And then we will look at the InSpec profiles that are created by the community members out there, the open source community. And to close it off, we'll have a look at how the journey continues. So comparing how we started at the beginning and what we had nearing the end, and then how we continue from that point forward. Now, let's begin with how the journey started. So it was really, probably you can say, one of the common DevOps projects, infrastructure project on the AWS as the cloud provider at the time. And I joined the project about halfway through, nearing the pre-production stage. So the project itself has a standard delivery pipeline. And I'm sure this is common for many people and for many organizations as well. So you start with a set of development environments. You move them to test environments for QA and testing purposes. And then you move on to stage, or some people like to call it pre-production. And then you go to production. Standard things, nothing unusual. Now, what was interesting is that after we deployed to staging environment, suddenly a group of people from another team showed up, and they're there to perform a compliance review. So compliance spanning across various aspects like security, configuration, and organizational requirements, things like tagging, billing code, cost center, and a lot of these other things. So, and I'm sure many of you have seen the Matrix movie. So this is Agent Brown. So it was a bit like that. Agent Brown showed up, and then I'm here to do compliance review. Give me the staging environment, and we'll check. And the whole process itself took a long time, about 3 to 5 days. So it wasn't by any means efficient, and it was just very risky. So to get an idea a bit of how the application looked like. So the application itself is called AEM. It's an enterprise CMS, and we're setting up a platform on AWS for this application. The network is standard, so it has private subnets, some DMZ, and then the public internet getting the content coming out of the enterprise CMS, standard stuff. AEM has several components. So authoring, where the content author generates produces the content for the websites, the web pages, and then a publishing component where those content are then published to the next stage. And then there is a web layer as well, where those content, those pages, and the assets are cached and be served to the public through this web layer. The publishing component can be scaled horizontally. So I'm just putting 3 here as an example, but it could be more. And same thing with the web component. So it can be scaled. Nothing unusual, still standard stuff. So on the publishing side of it, it has a data repository, like a database. So that's where the important content and configuration, some secrets as well, are actually stored. So parts of this content on the data repository can then be streamed to the web component layer. So in staging pre-production, the compliance review team ended up checking the authoring component, each of the publishing component, each of the web components, and the data repository setting, just making sure that everything is correct, right? Is secure, is compliant. Now, the problem is that after the 3 to 5 days, they produce a long spreadsheet, an Excel spreadsheet with all these different parameter checks with a checkbox each, and everything is ticked, everything is passing. Now, the problem is that luckily someone from the development team actually identified an incorrect configuration, and that caused the data repository to be accessible from the internet. So that means in that case, the whole data repository could be streamed outside to the public internet, including some of those secrets. So we were a bit lucky that that was picked up in staging, but and we fixed it. But when we went to production, we had to check a number of things for sanity sake, but it was hard to verify that everything is okay. So the $6 million questions at the time is actually, were we compliant? And no one could say for sure, because it took 3 to 5 days for a single environment to be verified. And even then, we had to rely on humans to be really diligent and be really careful about everything. So were we compliant? The best answer anyone can say was maybe. No one knew. So we identified 4 major problems really, and out of that initial pipeline delivery, we had to do manual correctness check. So after every application deployment, someone had to check a number of parameters about this application and making sure that it was the correct one that was expected. And then it's followed by manual readiness check. So after the environment was stood up, was everything really ready? Because all these various components, they all started in parallel, and a number of parameters could cause the application to recover. And it was really a manual effort to check the number of states across the components. And then with manual compliance check, that was the one that Agent Brown did, and it was done once per release. And manual compliance and manual security checks were the ones that were considered as the pre-production gateway, but it was actually inefficient and really time-consuming, and it's really error-prone. And having to do it once per release was not a great idea as well, because well, what happened if we have to build another environment? What happened if there was a catastrophic failure in certain parts of AWS, and then auto recovery came up, or we had to rebuild a completely new environment with different application version. So it was really bad. So the greatest lesson that we took, and this is really the if there is one message coming out of watching movie The Matrix, it is exactly what Agent Smith said here. Never send a human to do a machine's job. So when the humans did the compliance review check for our environments, it was really error prone, and we just simply couldn't rely on humans to do that. So we started looking for solutions, and yeah, lo and behold, we found Inspect. So Inspect, we started introducing Inspect, and it's coming to our rescue. So let's start by looking at what is Inspect. I'll try to define it in just a few simple points. It is an open source testing framework. So a lot of you would be familiar with testing frameworks, testing libraries, and Inspect is one of them. And Inspect is open source. You can have a look at the source code on GitHub. And just like any other testing framework, it checks the actual state of a system, and it then compares those actual states with the desired states that you define. So let's say you define that this system should have this particular parameter, so Inspect will check that. So the idea is that if you have hundreds upon hundreds of states to check, then you can use Inspect to perform that large volume of checking. And we found it very useful for testing application and infrastructure, obviously. That's why we adopted Inspect. But other than that, the fact that it was written in Ruby, technically, we would like to argue that anything that could be coded in Ruby can be tested. And that makes it useful, because we ended up using Inspect to do API testing, configuration checking, checking files on the file system, anything that could be coded, we ended up trying to code it at the various aspects of the system. So let's move to how can we use Inspect. So we'll just split it into 3 simple steps. So the first one, you write the test. The second one, you run the test. And then for the third one, you view the report. It's really simple, standard thing. Here's an example of a test file. So you can define a set of controls. So in my case here, we have Apache port control and Apache doc root. For each control, you can define the impact, like high, medium, low, or you can put a decimal number, 0.5, 0.9, 1.0. And you can also put up the title and description of these controls. So these titles and descriptions will then be used to show up on the report, and then you can get an idea what have been tested. And then you provide a describe, and in the Apache port testing here, I'm checking whether port 443, whether there is anything that's listening on port 443. So the check becomes port 443, there should be something listening to it. And then on the Apache doc root, I would like to check that the directory /var/www/html is actually a directory. So that's these two are just two of the simple examples that we use on the web component. And we're checking, is there anything listening to that port? Is the directory healthy and working? So why would we want to check something that sounds so simple? Even though it sounds so simple, that doc root directory actually came from a volume that's attached to the web component instance. And if the volume failed to be attached, then the directory wouldn't exist. So it sounds simple, but there are really high values in checking all these things, including checking the permissions, the ownership of the document root directory. And how do you use Inspect? So it's real simple. Just use the Inspect command line, Inspect exec, specify the file name, in this case, Apache tests.rb. And I added a simple example there to accept the chef license. And after you run the test, then you will view the report. So here's an example, a simple example as well from that Apache test.rb. And this is showing the Apache doc root testing as green, and it's tick with a tick in front of each line. It's showing that it is successful, that the Apache doc root is a directory. But however, port 443, there is nothing listening to that port. So it's failing, it's showing as red. And at the bottom of the report, you will see a summary, how many successful tests, how many failing tests. So that's the simple example of the test report. So with that, with the introduction of Inspect into our toolset on the project, we started writing a lot of tests. So what sort of tests that we ended up creating? The first one is the application correctness check. So this is testing the AAM application, the installation, whether it has the license file, whether it has the various critical directories, whether the data repository file exists, are the configurations correct and as expected, and are the API endpoints of this application working. Then we also added the next layer. So the first one is on the application side. So the next one is on the environment that includes this application. We are checking whether the AWS EC2 instances, whether those servers are ready to serve content, including checking whether the application is up and running and ready, whether it's healthy, whether the AWS instance itself is healthy. Does it have the right Java version, JDK version? Does it have the right security groups that would allow the networking around it? So various aspects around environment. And then the other types that we check would be the application security. So considering the security issue as one of the trigger why we look into adopting a testing framework for our infrastructure, we ended up writing these checks following AAM application security guidelines. So AAM does have a security guideline, which was followed manually by that team doing the review previously. So we attempted to ended up to code each of these security items and turn it into a set of inspect tests. And then at the organizational level, we are also introducing the environment compliance checks. So this is to satisfy the organization standard for things like labeling, tagging. Does each resource on AWS have the expected cost center, right? So was there any problem with the billing reporting from the completeness of the tagging and labeling across the resources? And this also involves checking the naming of the resources. For some resources, some other resources, we purposely give a unique suffix, but at the beginning, we have some naming convention for the prefix, and that's part of the compliance check as well. So armed with this amount of testing across various layers of the system, the next question would be, when did we run those tests? So previously we ran, well, a group of people manually ran those checks and tests at staging. So now because we have all these things as code, we introduce this on every server creation. So every time an AWS EC2 instance stands up, then as part of the cloud init script, we executed inspect tests as well. So it's running, checking the readiness of the application, the security setting of the application, the compliance, the organizational compliance for everything on that application running on the server. And then again, for the next layer, there are some checks that are more suitable for the whole environment, checking the multiple servers that are running within that environment. So we introduced an AWS Lambda function to then execute this various check across multiple resources within the environment. So the concept here is that instead of waiting until the end of the pipeline we would like for every environment creation, for every server that stood up, for each entity to then perform a self-inspection. The EC2 instance would run the test asking, am I compliant? And then for every environment getting created, it also asks itself, am I compliant? So those two tests improve the capability because when we created multiple environments, then each environment would be performing all these checks, and we would just be getting the automated repetition out of performing all these checks. If something is missing, then it gets picked up immediately rather than waiting until the closer to pre-production. So those two checks were more about self-checking when a resource came up. Now, there was also some scenarios where we needed on-demand checking, right? So the project used Jenkins CI/CD. So we introduced some CI/CD pipelines to perform various types of checking. So checking on the server level, in application environment. And why is this needed? It's because the server creation and environment creation check, the first two types of tests that we introduced here, they occurred at the beginning of the creation of those resources, but the environments might evolve along the way. There could be, God forbid, an emergency change that had to be applied. There could be some additional configuration drift that no one expected, but might accidentally happen for various reasons. And there could also be the scenario where suddenly it's audit time and someone needs to produce an audit report, and these checks need to be, the report coming out of inspect need to be part of that audit report. And yeah, usually this whole thing would just happen ad hoc and on demand, and that's why we introduced these Jenkins CI/CD pipelines to run those tests. So if we map these various tests and the various changes to the application architecture, now you have the, if you look at the blue rectangle, the blue areas, they're covering the server correctness, readiness, security, and test. And the cream colored area, they're covering the environment. So that's the mapping. So rather than someone checking one by one, so we have those components getting checked automatically. So is it all good? But it turns out not yet. We still had more problems, even though we introduced a lot of useful tests. We ended up with so many standalone test files, and it was really confusing when we had to think where to put this particular test. Should we put it in this file, in that file? Like someone didn't even realize that there were actually more files under certain directories. And there were also a little bit of duplications because not everyone was across everything that was tested. And the next problem is that different engineers structured the tests differently. It is because the engineers started working against user stories or feature requests. So all the various checks were based on the scope of the requirements. If a requirement is small, suddenly the engineer ended up a smaller test file covering just the parts that was implemented. And then if the scope of the feature request was massive, then suddenly we saw some either some small number of big files or many files with some checks with differing types of separation between those test files. And it was clear that there was no clear groupings between the tests, and it was just quite a mess. And not only that, because some of the engineers also started working on requirements for the organizational compliance, without realizing, we actually started writing some custom CIS benchmarks and AWS checking. So we used AWS SDK and actually implemented the AWS resource checking one by one. And not all of them, actually it was a small number, but it was beginning to be obvious to us that there's got to be a better way to do this. So that's when, as a group, we then looked at custom inspect profiles. So what is this inspect profile? So inspect profiles provides structure and style to the inspect tests. So the three important for directories here are controls, where you put the control files and the test files, and then there is a files folder for the input YAML configurations, and then you have the libraries. This is where the implementation of those desired state to be provided. And then, just like any repo, you can put in changelog and license and README. That's good practice. And you also need to add an inspect YAML that provides the metadata of this inspect profile. So let's look at the controls. So for this simple example, I have two controls. AEM application has a feature called CRXDE, which is useful for development, but it shouldn't be enabled in production. So I introduced a control called AEM CRXDE disabled. And for the second one, the control I have is the AEM SAML enabled. So the for enterprises, against a large organization, it's quite common to have single sign-on capability, and we wanted to make sure that for any non-development environment, then we have to have SAML enabled. So these are the two controls that can be used from the inspect profile. And if you look at the describe section there, AEM, it should have CRXDE disabled, and the second one, it should have SAML enabled. So where are those desired state implementation come from? So that came from the libraries. So you can have an implementation. It's basically just a class that extends the inspect resource, and you can give it a name and description and several methods, right? So the initialize method is common, just like any Ruby class. This is where I initialize an AEM client. AEM client is the one that provides the actual complexity. It's a Ruby library that provides the interaction with AEM, and that's where the complex code lives. But for simplicity of this example, I just have that client and would call just some methods from that client. And the next method is has CRXDE enabled. So this is the library implementation that was called from the previous control. So has CRXDE enabled calls the client and it retrieves the CRXDE status. If it is true, then that means it's enabled, and if it is false, then that means it's disabled. So it looks simple. So the libraries provides the implementation, and then controls can use that. And how do we run it? Again, it's inspect exec, just like running the standalone test file. But instead of specifying the test file, in this example, I put in just a dot there, just to indicate that it's using the current directory on a local file system. And I was just running this test from the inspect profile folder, and I added the show progress flag to provide the indicator of the progress of the test. And this is useful when there are so many tests to be executed from. And then for this example, I also specify what controls you want to supply. So in this case, I just specify those two controls that were defined in my control files. But in practice, then you can have your inspect profiles might have hundreds of controls, and then you can just execute some controls depending on where you want to execute them. So similar to the standalone execution, you have the report. And for this example, I'm just showing that both checks ended up failing. And in this case, the response is unexpected. The scenario I was testing is that AEM failed to start and there was nothing responding to the check. So in this case, the check whether AEM CRXDE is disabled, it failed, and whether SAML is enabled, it failed. So after discussing about how we wanted to use these inspect profiles, we decided to create 3 types of inspect profiles. And this is where we wanted to start introducing the better grouping between the tests, some sort of a domain. So the first one is inspect AEM. The domain it's covering is the single AEM application. So any test that is to do with a single AEM application goes to this inspect profile. And oh yeah, we ended up open sourcing it as well. So it's available on GitHub at the URL there. And the second one is inspect AEM security. Just because security is so important, then we decided to actually encapsulate the implementation of the AEM security guideline into its own dedicated inspect profile. And the third one is the inspect AEM AWS. So this is at the environment level. So the knowledge about the architecture, the servers, the multiple types of components containing multiple installation of AEM, that knowledge lives here. So on inspect AEM, it only knows about AEM. It doesn't know whether it's using AWS as the cloud provider or any other cloud providers. On the security side, it only cares about security, right? So on the inspect AEM AWS, it is the implementation about the AWS layer, but not so much on the AEM configuration itself. So we introduced these 3 domains, we open source them. So we're all problem solved. So not really at the time. Not all of them, but we already solved 3 out of the initial 4 problems that we identified. So for many standalone test files, we solved that test files are now part of the inspect profiles, and there is a place to put a new test. So if the next engineer picked up a new feature requirement, then the person can decide whether that testing has to be added to inspect AEM at the application level or at the environment level, or is it security specific, or should we introduce a new domain? And then the next problem, different engineers structure the test differently. With the introduction of inspect profile, everyone ended up following the inspect profile style guide, follow the same directory structures, come up with some naming standard, and it's consistent. It's easy for a new member of the team to then be familiar with where to put this piece of test and how to structure it. The other problem with no clear grouping between tests, that's also solved because we separate those inspect profiles by domains. So it should be obvious whether it's part of the existing domains or should we introduce a new domain. So we implemented these 3 inspect profiles and open source all of them. So the next question would be, how did we distribute them? So that's where we started using Chef Supermarket. I'm going to show you the simple form that we used to add inspect AEM. So if you go to Chef Supermarket and then log in with your account, then you can add your inspect profile as a tool and specify the name, slot, the type of this inspect checks, where is the website URL, and then submit it. So we registered the 3 inspect profiles that we open source. So Chef Supermarket becomes like a discovery, a registry for all these inspect profiles. And our plan was for our the project that we worked on to consume these inspect profiles, but at the same time, we also work on other projects within another organization that ended up consuming the same set of inspect profiles. So there is a level of reuse there, and it's very useful. And in fact, we found out that there are other organizations out there just use some of these inspect profiles as a standalone, and they integrated these checkings against their own implementation, which is great. That's what we want from open source, right? So it's something that's useful. people start using it, and hopefully people will start contributing to it. Now, how do we use inspect profile as vendor dependencies? You can specify it on inspect YAML. So specify a file like this. In this example, I describe the dependencies with name and URL. So it specifies the URL to directly to the package file, which is a target zip. But if we just want to use the supermarket distributed packages, then you don't have to specify the URL. You just specify the username / the package name. So in this case, it could be Shine Solutions / AEM-security. And then we just run inspect vendor command, and inspect vendor will download those packages into the vendor directory. It's really straightforward. And then you have these packages residing on your local system. Okay, so after open sourcing those three inspect profiles and started using Chef Supermarket, we started looking at the community inspect profiles. This is the attempt to solve the one last problem, which was we started writing some CIS benchmarks and AWS checks. Let's start a bit with what CIS benchmarks are. It is really a set of configuration guideline for securing a system. And it was built by an organization called the Center of Internet Security. Then they're collaborating with various technology communities into coming up with a set of guidelines on how to best secure various types of systems. So back then, our project started implementing some of these benchmark rules, and without realizing, then we kept doing it, and until to a point, then we started asking ourselves, surely there's a better guideline here that we can use. And lo and behold, not only the benchmarks were there, but the community already implemented a number of these benchmarks. So for example, DevSec framework, the DevSec project, they already came up with CIS Linux benchmark, which we use for securing our Red Hat 7 AWS EC2 instances. And then the CIS Docker benchmark coming from the same DevSec group, it's used for securing the Docker images that we use for running the CI/CD pipelines. And then another organization, MITRE, they implemented the CIS baseline for AWS Foundation, and we use that for securing the AEM on AWS environment. And last but not least, one of the problems we hit back then, we started implementing some libraries using AWS SDK, and it turns out there is already Inspect AWS. So we use that for checking the compliance against various AWS resources. So instead of using AWS SDK, we can straight away just use the libraries or the controls that are supplied by Inspect AWS. So after knowing that all these various community solution for CIS benchmarks already existed, and combined with our Inspect AEM security, the last improvement that we made was actually more on the non-technical side of it, more on the mind side. So we started asking ourselves, what is the definition of infrastructure readiness and correctness? So previously, we were just thinking that, oh yeah, this application has the right configuration, this environment has the right configuration, but we would like to push that a bit further. And we started asking ourselves, like, what could be better? And we wanted to change our mindset into thinking that if it is not secure, then it's not correct at all. If it is not secure, and we cannot consider the application, the server, or the environment to be ready. So security should be part of the correctness and readiness. If it's not secure, then it's not ready. As simple as that. So that was the one last improvement that we added to the project. So now to close it off, how the journey continues from that point on, because obviously security, compliance, review, improvements, it's all a journey. There's no finish line. So if we compare that to how we started, right, with the delivery pipeline before we introduced Inspect, we had someone from the Matrix showed up one day before production and perform a number of compliance review check for 3 to 5 days. So we replaced that with Inspect, test, from dev to test to stage to production. And these are the same set of tests for the same version of environment. If there is an improvement to the test, then we will release a new version of the tests. And by introducing this along the way, we didn't wait until the end of the pipeline. We introduced that as early as possible on the delivery, throughout the delivery pipeline. So we ended up introducing what we call continuous compliance review. It didn't just wait until the end, it went through the whole pipeline. And then from the application architecture point of view, this is how it looked like before Inspect, a set of manual checks along the way. And then after Inspect, we actually have Inspect checks on every server and on every environment, making sure that all the security and compliance requirements were met. So if we return to the $6 million questions, were we compliant? Then we could say that, yes, we were compliant. And the proof was really coming from the continuous compliance review, because we simply just produced the report for the various checks on every server and every environment creation. And instead of not being sure whether we are compliant at all, we could say definitely that we are compliant, and the test reports were the proof. So to summarize this talk, what were the lessons learned? The first thing is really we found Inspect to be a really useful utility belt that we added to the project. And yeah, we used it for testing anything. Other than the ones that we open source, there were some other internal tests that we also added. And yeah, Inspect as a framework, it just provided the right capability to implement this types of checks. Yeah, and obviously we need to leverage the Inspect profiles from the community. So first thing, check the Chef Supermarket before you start implementing your tests yourself, and see if there's anything useful there. And there are actually lots of useful security checks, as I showed you before. And if you need to test something once, it's very likely that you're going to test it again. So it might as well automate that and implement the tests. You want to execute the test early in the delivery pipeline. Don't wait until the end of the delivery pipeline. That was already too late. Implement your tests along the way from the beginning as early as possible. And the last lesson learned here is still the one from the Matrix. Never ever send a human to do a machine's job. Thank you. Thanks, everyone. Is there any questions?
I have some questions for you. So the process sounds almost daunting, but not like not impossible, right? It just sounds like it's a lot of investment. How long do you think folks should expect from the moment that they from the moment that everyone agrees that we need to implement this and this is the tool and that kind of stuff, from that moment to you know, we are compliant? How long do you expect that journey to take?
Oh, okay, to achieve compliance. Well,
Yeah.
for that, well, I would say it varies depending on projects, but for that one particular project, the implementation alone probably took a couple of months, just because we had to coordinate between various teams, getting buy-in from other teams. From within the team itself, everyone immediately agreed after that initial journey and how everything was done manually. And as soon as we started talking, hey, we need to automate this, and everyone would just nod, and everyone is in agreement within the team, right?
Yeah.
So everyone started working on really the buy-in and getting the ball rolling.
Yeah.
And yeah, the major time saver there was definitely the CIS benchmarks, inspect profiles, because implementing them ourselves would be a major undertaking. So that would have saved months upon months of effort. The AEM implementation itself, I think majority of the 2 months effort actually covered the implementation of the application checking. But once we have it there and open source it, then the next project actually would save like 1 month, right? So, and they can all focus on their own internal checking that is specific to their application, to their system, right? So, whereas the common parts, hopefully, just reusable inspect profiles.
That's awesome.
Yeah.
That's awesome. One of the complaints that I hear about, completely shifting gears, one of the complaints that I hear about compliance monitoring in general, not necessarily inspect specifically, but compliance monitoring in general, is that you can't really trust the results because it is a computer, right? So like, who knows if there's something else going on or something like that. Is there anything that you feel like you've encountered that like, no, really a human needs to check for this thing, or like anything that inspect or any of the other compliance monitoring tools don't cover? Or is it something that you really can put your trust in?
Right. Well, that's an excellent question. Yeah. So with all these releases, and especially for the more conservative organization, sanity checking is always going to be there, regardless. So I still have. Well, I'm still working with a lot of enterprises, so I have to deal with Excel spreadsheets still and run sheet and all those things, and it is still unavoidable, I would say. Having said that, though, for organizations that are more nimble, I can imagine systems where we actually discussed this within our team as well. It's more like something that we would like to do at some point, but not necessarily going to be easy to introduce. Some sort of like a second level checking. So we run all these tests, and then at the end of the pipeline, have a second layer checking that doesn't have to check everything, but check the top 10, the highest value checks that need to be done, or some randomized testing that checks everything at random time. Introduce a little bit of like Chaos Monkey, but not at the server level, but Chaos Monkey at the compliance level. I don't know if someone will come up with a chaos compliance. that probably will be interesting. Just put the system here, and it will check, feed it your compliance requirement, and then introduce chaos to it and see which systems actually are still compliant. And I mean, many ideas, but it will be interesting to see the improvements that will come up within the space.
Yeah, awesome, cool. Well, I don't have any other questions for you, so I think we're gonna call it. Thanks everybody for joining us today. Welcome, enjoy the rest of Chef Comp, and thanks Cliff for presenting today.
Thank you. Thanks a lot, Benny.